We're going to compare the properties of lithium, sodium, and potassium, both some physical properties and some chemical properties. So I have them all three here. And let's see, I need you two and you two to go somewhere safer.
Science good demo, right, guys?
So there's lithium, sodium, and potassium. I store them under mineral oil because they are quite reactive. They'll react with oxygen in the jar, and oxygen that diffuses into the jar. And if I leave them there without mineral oil, they'll come back in a few weeks, and I'll have lithium oxide, sodium oxide, and potassium oxide. Actually, probably lithium hydroxide, potassium hydroxide, and sodium hydroxide. So they're all members of the same group. Sometimes these are called groups of families. You'll still occasionally have chemistry books called families, and they usually name it after the top one, like the lithium family, the beryllium family, the boron family, carbon family, nitrogen family, oxygen family.
I don't even do that, and I'm pretty old.
I'm old. And I do. But I like it because if you ever had a friend that you've known for a while, and you never, after several years of knowing them, you actually go back and meet their family and you meet their brothers and sisters. And it's kind of weird because they're kind of the same, but different. That's the way families are, right? I mean, they have similar properties, but slightly different. You know, maybe one's got a big nose, their brother has a little bit bigger nose, or whatever. So we're going to look for those kind of things. Properties that are the same. We're not only going to identify the properties that are the same, but also try to identify trends in the properties. Which ones, okay, they have that property, but maybe the other one has that more so. So let's take a look at these in order. Let's start off with lithium. There's some lithium. It looks dull gray on the outside. That's because it's got a coat of lithium oxide on it. Actually, this is basically a spatula. It's a butter knife. This is an unusual thing about a metal. I can cut it with a butter knife. And right where I cut it, you might see it's kind of shiny. And there you see the metallic aspect of it.
Oh, I thought you were going to do the big piece.
Oh, with lithium is just boring.
Just go on.
Okay, so I've got some water over here. I'm going to drop it in water and we're going to see what happens. Now, so as far as in terms of how soft it was, kind of about as hard as Parmesan cheese, not the cheap stuff that you buy that's already grated, but the expensive stuff that you can't afford yet because you're a college student that's not grated yet. Okay, so it's about that hardness.
On the cheese.
On the cheese. Right. So we're going to put it in here and try to react it with water. So one of the physical properties we know already is fairly soft. And let's see how it reacts, or if it reacts with water.
It's pretty exciting.
No, it's not. But it gives us a basis of comparison. So is it reacting?
Yeah.
Let me guess what the products are. What are the reactants? What are the reactants?
It's doing glass.
Yeah.
So what are the reactants? Lithium and water. What are the products?
Reaction you should know, guys.
Lithium hydroxide.
Lithium oxide and hydrogen.
Yes.
Metal oxides react with water to make metal hydroxide. I do another demo where we look at the basicity of the water.
All right.
Okay, good. So it reacts with water that way. That's a good thing.
What's the
By the way,
gas?
you also notice another physical property. What about its density? About its density relative to mineral oil? Less than. It's floating. Now here's some sodium, and you'll notice that it again has a a coating on it of oxide that I cut through. And when I cut through it, you'll see again a metallic surface.
Wensleydale, would you say?
Right there. And I don't know. I never could afford that. I'll go with a cheddar or a Colby. It's a little bit harder. This is the cheese scale, and yes, you can feel it. Cheese scale of hardness. So we went from Parmesan to cheddar or Colby. So in terms of hardness or softness, we notice that they have that same physical property. They're both fairly soft, particularly for metals. But we see a trend. So would you say cheddar is harder or softer than Parmesan? Softer. Okay. Then we'll take this and put it in our water and see what happens. It immediately melts. Oh, the flame! Yay! So,
Yeah.
So is this,
Don't breathe that stuff.
yeah, don't read that stuff. Is this more dense or less dense than water? Less dense than water. More dense or less dense than mineral oil? More dense or less dense than lithium? Yeah, okay, good. All right, so that's sodium. Let's take a look at potassium now.
Okay, we got some potassium.
We got some potassium right here.
What kind of cheese you think, guys? Blue scale. Blue? Feta?
It's not that crumbly.
Camembert.
Camembert, definitely. I think we got that. And it's shiny and immediately starts to grow.
And it's from really pretty purple oxide.
Yeah, I'll go with a Gouda or Camembert. Okay, so here we go again. And here is potassium. This. That.
Oh.
More reactive or less reactive than hydrogen? I mean, sodium. Think of the time. Those were about the same size chunks. Did that react quicker or slower? Much quicker, yeah. What physical properties did we observe that were similar?
They react with water.
What physical properties did we observe?
Soft.
What's the difference between physical and chemical property? We observed chemical properties too. Physical properties are properties that are determined without trying to react it with something or change it into a different substance.
It would
Doesn't
be
mean
like
you all.
melting point, density,
So what?
color.
What physical properties did we observe?
Very solid.
Soft. And what was the trend? Got softer. Color. Yeah, they're all kind of metallic and metallic luster, or not color, but the luster. They all have metallic luster. Density. They all floated in the water. Lithium floats on the mineral oil, so I'm going to guess we're getting denser as we go along. How about chemical properties? What chemical properties? Reacts with water.
Faster than.
And you notice this, they all have that property, but there's a trend, and the trend goes increasing reactivity. What does that tell us about how tightly that outer electron is held? Less tightly as we go down? Okay. Cool.